go over 3 theorems with you that have to do with perpendicular lines. If 2 lines intersect to form a linear pair, which is a linear pair, 1 and 2 make a linear pair, then the lines are perpendicular. Well, we know there's 180 degrees in every straight line, and these are going to be congruent to each other. 1 and 2 are congruent, and then line G will be perpendicular to line H. In the perpendicular transversal theorem, it says in a plane, if a transversal is perpendicular to one of 2 parallel lines, he's perpendicular to one of them, and these are parallel, then he is perpendicular to the other line. So I would be able to put my little box here as well. So if H and K are parallel, and J is perpendicular to H, then that means J has to be perpendicular to K. And then this one, the line's perpendicular to a transversal theorem. In a plane, if 2 lines are perpendicular to the same line, so here's the line P, M and N are perpendicular to it, then that means that M and N are parallel to each other. Now look at this diagram here. I want to prove which lines are parallel, if any, which lines are parallel, using one of the 3 theorems that I just studied about. So determine which lines, if any, must be parallel in the diagram. All right, lines P and Q are both perpendicular to this transversal S. Think of it as a transversal S. You can hide this if you want to see less. So if that's the case, by the lines perpendicular to a transversal theorem, that means P must be parallel to Q. Because of these 2 boxes here, I can say these 2 are parallel. Now, let's kind of ignore this line and look at these 2 boxes here. So I've got S and T that are perpendicular to this transversal Q. So if that's the case, I have these 2 perpendicular here, that means S and T are parallel. Lines S and T are both perpendicular to Q, so by the lines perpendicular to transversal theorem, S must be parallel to T.